Right. Good morning. Today I will explain quantity and quality of water. So first of all, go to quality of water. So for determining quality of water, first of all, we have to collect sampling from sources of water. What is sampling? Sampling means a representative portion of water collected from the source is known as sampling. The process of collecting a representative portion of water as from the natural environment or from an industrial site for the purpose of analyzing it for constituents. The process of taking portion of water for analysis or other testing is known as sampling. Drinking water to check that it complies, or river water to check for pollutant, or bathing water to check that it is safe. So the main purpose to check the quality of water, compulsory we collect the sample from various sources. So the primary goal of water sampling is to observe and measure how water quality changes over time. An important premises to water sampling work is that high acidity or high alkalinity in the water might be normal for given environment or ecological region. Water samples must be taken and analyzed repeatedly over a period of weeks, months, years, and decades to determine more precisely how water condition changes. So types of sampling, two types. One is graph sampling and composite sampling. Graph sampling mean the collection of water sample at a particular location and time, and just beneath the water sample is known as graph sampling. Composite sampling means various graph sampling, number of gram sampling collected and mixed based on proportion is known as composite sampling. So the quality of water is mainly classified three types. One is physical, chemical, and bacteriological impurities. So main is physical characteristics, color, odor, and taste, and temperature also. Temperature and turbidity. So temperature around 10 degrees Celsius desirable, above 25 degrees Celsius objectionable, because 10 degrees at temperature 10 degrees bacteria cannot survive. That is the reason at 10 degrees Celsius is good for drinking, and above 25 degrees the bacterial activity is more. That's why so generally is objectionable for drinking water. And color, pure water is always colorless. Color is mainly due to presence of suspended and due to dissolved solids, and generally this is measured in Hazen units. For drinking water it is below 5 Hazen units good, but is allowed 25 Hazen units. There is no alternative sources of water. And taste and water, pure water is free from taste and odor, but is mainly due to the presence of dissolved gases. Water is measured by the TON number, threshold water number, and this formula A plus B by A. A means right volume of sample, B is equal volume of distilled water. For public supply, TON number is a good below whenever less than 3. And is instrument, which instrument is it means osmoscope is used for water test. At the same time color tintometer is used for measuring color. And turbidity means so that is the main presence of suspended solids is represent, and this is main due to the presence of clay, silt, and other rock fragment. This is a working principle of light scattering. Whenever light passing through the water, in case any particle present, that light is touch the particle and scattering. The scatter light directly proportional to the presence of turbidity that is measured. It generally used NTU is latest units on NTU, nephro turbidity units. Desirable limits, right? 10 NTU is desirable. Come to chemical parameters. There is many chemical parameters: total solids, chlorides, hardness, pH, and alkalinity, acidity, nitrogen content, and other metals, dissolved gases. Solids is classified various types: suspended solids, colloidal solids, dissolved solids. That is based on size, and based on its character is classified two types: organic solids and inorganic solids. Water is generally drinking point of view TDS, total dissolved solids, very important. That is measured with the help of conductivity meter or in laboratory by evaporating water after filtration or 1 micron filtration. Chloride is mainly present in the form of sodium chloride. That is right, due to leaching of marine sediment deposits, pollution from seawater, industrial and other domestic wastewater is region. Right, this value is 250 mg per liter below is good for drinking, and a high quantity of chloride indicate is contaminated or some various sources. Maybe water supply pipes whenever testing is increasing high chloride, that indicate is mixing some wastewater along the along the pipeline. Determining by titration with standard silver nitrate solution by adding indicator potassium chromate. Hardness is mainly causes due to the presence of divalent ions. Hardness is right. It's classified by two types. Is a carbonate hardness and that is a non-carbonate hardness. Means permanent and temporary hardness. Main temporary hardness due to the presence of bicarbonates, carbonates of calcium and magnesium. And permanent hardness or nitrate, chloride, sulfates of calcium and magnesium. This right. The main character is prevent leather formation. That is the main character. This is measured in expressed in ppm mg per liter. Especially groundwater is contained groundwater. Using right EDTA solution used right for measuring this hardness of water. Groundwater contain more hard than right surface water. This pH means potential of hydrogen ion concentration. The main definition, negative logarithm of H plus ion concentration. It indicate what is right is water is neutral, acidity or nature, alkalinity. The pH scale is varying 0 to 14. Is below 7, that is right, acidic nature. Above 7 is alkalitic nature. Is as per Indian standard, this value should be between 6.5 to 8.5 for drinking water. Acidic water cause corrosion. Alkaline water is a formation of sedimentation, means scales are formed. Alkalinity caused by carbonates, bicarbonates and hydroxides of and sodium, calcium and magnesium. Excess alkalinity causes bitter taste, sedimentation deposits in pipes. This also is measured in terms of ppm, and this is measured in laboratory by titrating against H2SO4 by adding methyl orange indicator. Acidity, mainly acidity two types, mineral acidity and carbon dioxide acidity. Mineral acidity mainly from industries, and carbon dioxide acidity is nature, from nature, and it is measured by with the NaOH, by titrating NaOH by adding methyl orange indicator and phenolphthalein indicator. Is a nitrogen and its components. So nitrogen indicates presence of organic matter. Occurs as free ammonia and albuminide nitrogen, nitrite and nitrate. It's a nitrate is the right end product. Nitrate is greater than 45 mg per liter nitrate that may cause blue baby syndrome or methemoglobinemia. That is right. Free ammonia, first stage of decomposition. Organic nitrogen before decomposition. Nitrates partially decomposed and nitrates fully decomposed. This right, free ammonia limits 0.15 mg per liter. Organic nitrogen 0.3 mg per liter. Nitrates very dangerous, so limits is 0. Nitrates concentration in domestic water supply limits 45 mg per liter. Methylglobinabia, that is a right blue baby syndrome whenever presence of more nitrate. There are some other metals like ferrous, manganese, copper, lead, cadmium, chromium, arsenic, and fluoride is present in water. That should be right within the limits. Should be right. Ferrous and ammonia, right, should not exceed zero point 0.3 ppm ferrous and 0.05 ppm manganese. Import, right, as a color of water, that is whenever ferrous present, iron present, whenever washing cloth is a discoloration of clothes. And fluoride, it should be in between 0.8 to 1.0. If less than 1.8, that is called formation of cavities on young children, and greater than 1 ppm, that deformation of bones. This picture shows dental fluorosis and skeleton fluorosis, especially presence of fluoride, excess fluoride in water. Dissolved gases, it's a special right, carbon dioxide and hydrogen sulfide. DO, dissolved DO, that is a very important for surviving aquatic life. That value should be 4 mg per liter. If less than 4 mg per liter, the aquatic life cannot survive. DO content at 0 degrees Celsius 14.4 and 10 degrees 11.33, 20 degrees 9.2 mg per liter, at 30 degrees 7.6 mg per liter for pure water. More DO increase corrosivity. That is another problem. This is a carbon dioxide, is a dissolved form atmosphere from decomposing organic matter. Higher carbon dioxide, it makes acidity in water and may cause corrosivity, and higher carbon dioxide imparts taste and odor also. H2S found in groundwater produced by reduction of sulfate or by decomposition of organic matter. If present, it gives a bad smell, or we can't bear the smell, rotten egg smell. And biological quality parameter, there are many biological bacteria, but especially is waterborne diseases mainly causes E. coli bacteria, that is E. cercia bacteria, that is a type of pathogenic bacteria. So that is bacteria is classified based on mankind. One is harmful and harmless. Harmful bacteria is pathogenic, harmless bacteria is non-pathogenic bacteria, which is beneficial to the human being. If present pathogenic bacteria, that is may cause waterborne diseases, especially E. coli bacteria. As per Indian standard for drinking water, is a code as given, Indian standard 10500. There is a right, two limits as given. Desirable limits means within desirable is good for drinking, but permissible, will give the permission in case there is no alternative source. Will give the permission. Is as per code, is color 5 desirable limits, 25 permissible limit. Water is unobjectionable. If you do like any water and taste, we can drink, right? And turbidity 5 NTU desirable, 10 NTU permissible. pH value should be 6.5 to 8.5. Hardness, right, 300 and 600. Iron 0.3, 1.0. Chloride generally within 250 below is good. We allowed up to 1000 mg per liter. Residual or free chlorine 0.2. Fluoride 1 is desirable limit, 1.5 permissible limit. Like TDS 500 is good, up to allowed 2000. Calcium 75, 200 is permissible limit. magnesium 30 and 100, copper 0.05 is desirable, but we allowed 1.5 mg per liter. Manganese 0.10 or permissible 0.3. Sulfate 200 and permissible limit 400. Nitrate 445, no relaxation, and right there are some high metals 0.001 is desirable, allowed 0.002, like mercury 0.001, cadmium 0.001 good, up to below. Selenium also 0.01, arsenic 0.01, cyanide 0.05, lead 0.05, zinc 5 is good, below 5, and some detergent 0.02 is good, chromium 0 below 0.05 good, and mineral oils 0.01, pesticides it should be 0, and radioactive materials is not allowed. Alkalinity 200 is good, below, allowed up to 600. Aluminium 0.03 is good, below, and 0.2 is allowed. This bacteriological examination generally is examined by using E. coli test or standard plate count test or membrane filter techniques. But drinking water should be free from pathogenic agent, free from harmful chemical factors, pleasure to the taste when we consume, usable for domestic purpose. These are the again standards. What is only desirable limits given, only this main check the in laboratory general quality of water. This is a color, taste, turbidity, pH, TDS, oddness, chloride, sulfate, nitrates, fluorides, calcium, residual chlorine, iron, manganese, and total bacterial. Next, second topic is the source of water. The main source of water is precipitation. This precipitation is falling on ground in various form, in the form of rain, snow, hail, sleet, ice, like that. Whenever falling this precipitation onto the ground surface, it can distributed in three forms. One is percolating into the ground and evaporated into the atmosphere, and some water is overflow the ground. It's technically is called runoff water. The rainwater is the main component. It's a water source. This is water vapor condense and return to the earth as a precipitation. Once again, replenishing reservoirs, lakes, and rivers and other source of water. Much of the rain that enter the ground filtered down into subsurface is called formation of water bearing strata. Yes. This is the main sources of water. One is surface water, and subsurface water is called groundwater. Surface water, streams, ponds, rain, that is impounded reservoirs, and rivers, lakes. This all are belongs to under surface sources. Underground source, or that is wells, springs especially. And we constructed some infiltration galleries and infiltration wells along the river. Porous, that is these wells water is open wells or tube wells, two types, springs or artesian springs and gravity springs types. So streams and rivers, the main difference streams and rivers, these are natural channels. Both are natural channels. Streams is a small channels along which water is continuously flowing towards a downward slope and made of small gullies. River is a large channel along which water is continuously flowing towards the downstream and made of many streams that come together. All rivers and streams start at some high point. The high point can be a mountain, hill, or another elevated areas. Water from source like a snow, melt, or lake start at the high point being to flow down to lower point. As the water flows down, it may pick up more water from other small streams. These streams may slowly join together to become large rivers. Is the picture shows rivers is a Ganga river is a top picture shows this is Kashmir stream. This right suitability is a main large cities is the rivers are main suitable and streams the quality is a flowing water it pick up various kinds of impurities. That's why proper degree of treatment required before supply water from the rivers and streams to the public. Is the main source of water main. And lake is a pond. The main difference lake and pond. Lake is a natural halo of forming on Earth's surface, and ponds are man-made. The small water deposits. That is generally formed is glaciers, rivers, and wind currents. The quantity of water in the lake depends on its basin capacity and catchment area and annual rainfall and porosity of ground, that is right as a geological condition underground. Millions of lakes are scattered over Earth's surface. Most are located in higher latitudes and mountain area. The Great Lakes of the United States and Canada are the world's largest systems of fresh water. Canada alone contains almost 50% of the world lakes. Is Titicaca Lake, South Africa, is one of the largest lake, is one of the best source for drinking water. Is right when compared to lake pond, right? So lake water is good. Pond is small, right? Small, natural or artificial. That is usually smaller than lake. They may arise naturally in floodplains as part of river system. Impound reservoirs. Impound means is nothing but artificial lakes which is constructed along the valleys by constructing small dams or it is also known as storage reservoir. Sardar Sarwar Dam is Gujarat, it's one of the dam. So that is springs is one of the groundwater, underground water. Springs typically are present where the water table intersect the land surface. Springs can discharge fresh groundwater either onto the ground surface, directly into the beds of river or streams, or directly into the ocean below the sea level. So this is called infiltration galleries. Generally, it's constructed along the rivers, along the river, where water tapping from the ground from the river. This water is good for drinking without any treatment. We can directly supply to the public because almost is purified with the help of the river bed. That is the right one of the this is the right river this bed. From the bed water infiltrated into the pipes, open jointed pipes, and collected water, and this maybe length is varying up to right 10 to 100 meter. This is one side is provided slope, and this infiltrated water where the slope is provided, one sump is constructed from where water filtered and supplied to the public without any treatment. Is a wells is a excavation over the earth by digging or driving or boring or to access groundwater in underground aquifer. A well is a human-made hole in the ground specially used for the accessing groundwater. Wells comes in different shapes and size, but their use is generally the same. Is a dug well, driven well, and drilled well. It's simply say open well and a tube well. As a dug well, this is a open well, as a excavated. This is right with the help of the machinery or human beings. Maybe this is either lined or without line is provided. Dug wells have a large diameter and expose a large area to the aquifer. This well is able to obtain water from less permeable material such as very fine sand, silt, or clay. is a driven well, that is a bore well. Bore wells are is extracting water from different layers. That is right. Yield is more when compared to open well, and that is right. The pipe has a filter over the bottom to keep out as much sediment as possible, and pipe is driven down into ground until it reaches the water table. This right, once the well is deep enough, all of the dirt is washed out of the inside of the pipe, and a pump is installed so that water can be removed from the well as continuously. This is a drilled well, right, up to go to right 1,000 feet with the help of bore. Is a difference is a open well of only extracting from top layer, driven point we extracting, that is two, that is a deep open well, 2 layers, and drilled well we extracting water from different layers. Is a artesian well. Artesian well means in well where one spring is formed within the well, that is artesian well. When artesian well is formed, it supply water throughout the year, right? Even summer also available water, that is artesian well. It is formed different between two impervious layer. One pervious layer whenever forming, that pervious layer where existing, that places is known as artesian well. This is capable to supply water throughout the year, right? Infiltration wells, these also constructed along the river bank. Just as wells are constructed, and water is tapping from river bed to into the well. These all wells are interconnected to the one sump well, that is technical we called jack well. This radial this jug from where water is lifting and supplied to the public. You see, generally these right infiltration wells are constructed with the masonry wall with open joints, and the top is closed, and one manhole is provided for inspection purpose. Choice of the source, one is any source, mainly we how to select, right? Many sources is available for domestic point of view, that time, right? We how to choose which source is good, surface source or underground surface, that is the main. We follow the 4 points, right? Especially one is quantity. One is we check the quantity of water any source. That source should have capable to supply the water throughout the year. That type of source we selected first initially. Next, okay, the same quantity sources is available, 2 or 3 sources. The source have capable supply throughout the year. That time, which source is quality is good, we choose. Is a minimum treatment which source, right? That is we selected. Then right is a good quality also good, is available 2 or 3 sources. That time is a location, location of source is which location is good, right? So far away or near the town. Generally we selected near the town. But topography, what is the topography in between? Is there any hills or valleys is available? That is not avoided. Whenever plain area, that is right. Location means upstream side location is good because we can carry the water by the action of gravity. That is good. And next, how to write water is collection and conveyance from the surface sources. Right, collection and conveyance of water generally by constructing intake structure. This is called reservoir intake structures. This intake, what is intake structure means? That intake is a right. Which is the device or structure installed for the purpose of drawing water from the source of water are called intake. In any water supply project, the first step is to select the source of water from which water is drawn. How to draw means by constructing a intake structure, right, or intake well. Selection of site for intake well. The site should be near the treatment plant to reduce the conveying cost. Intake must be located in the purer zone. Intake never located where the wastewater disposal or vicinity of wastewater disposal. Intake must never be located near the navigation channels, and also where the curve the site should be such as to permit greater withdrawal water even summer season also. This is one of the picture selecting location of intake structure, where access should be good and purer zone, and should never be right located in the curves. Right, this is one of the intake structure. It's collecting water from the source, then by the action of gravity is collecting and supplying it to the public. Right, is another picture. It's intake structure. Right, thank you. Right.